Alright guys, welcome back to another Math Notes. This is 3.1.6 parallel and perpendicular lines. We'll just roll right into it with a couple definitions. Parallel lines are lines that lie in the same plane, i.e. on a flat surface, and never intersect. Line L and line N at the right are examples of parallel lines. We can see that line L and line N will not cross each other, just like railroad tracks or sides of a road or edges of walls do not intersect. The slope of parallel lines are the same. If a line has a slope m, the slope of any parallel line is also m. In this case, in our little example of line L and N, we have a slope of 2 over 1, 2, 3, 4. 2, lovely. 2 over 4, which reduces to 1/2. And our parallel line should have the same slope of 2 over 4 or 1/2. So the slope of N equals the slope of L. On the other hand, perpendicular lines, so now we're down here on perpendicular lines. On the other hand, perpendicular lines are lines that intersect at a right angle. That is critical to know, guys. A lot of students forget that last bit. They intersect at a right angle. They make 90 degrees. For example, lines T and N at the right are perpendicular. The small square drawn at the point of intersection indicates a right angle. So here's line N, here's line T, and here's that 90-degree square that they're talking about. If we take a look at those slopes, N, again, which we already just found, has a slope of 2 over 4, which reduces to 1/2. So the slope of N equals 1/2. And T has a slope of negative 4 over 2. Now it's negative because it goes down 4, right 2. So when we go down, we get a negative slope. And so the slope of T equals negative 4 over 2, which reduces to negative 2 over 1, or just negative 2. The slopes of perpendicular lines are opposite reciprocals. For example, if one line has a slope of 4/5, then any perpendicular line has a slope of negative 5/4. So we flip the fraction and change the sign. Let's take a look at lines M and T again. Line M had a slope of 1/2. Line T has a slope of negative 2 over 1. So if we flip 1/2, we get 2 over 1, and we change the sign, we get negative 2 over 1. So that rule still holds true. And continuing here, if a line has a slope of negative 2, then any line perpendicular to it has a slope of 1/2. In general, the slope of a line perpendicular to the line with the slope of M is negative 1 over M. You can write the equation of a new line that is perpendicular to an existing line and goes through a specific point. That's handy. Sometimes you'll get problems that'll ask you to do that. For example, write the equation of a line that goes through point 4,5 and is perpendicular to y equals 1/2 x plus 1. And they have that drawn out for you here on the right. There's 0.45. Here's the line y equals 1/2 x plus 1. And we want to find the equation of this new perpendicular line that I'll do in red that goes through that point and crosses at 90 degrees. Well, the first thing we're going to do is find the slope of our new line. To do that, we're going to find the slope of the original line, which was 1/2. We know that by looking at the equation. do that in blue. That is 1/2, or by counting the graph, since we have it nicely graphed. Up 1 over 2. Okay, so the slope of our perpendicular line, we're going to flip it and change the sign, is going to have a slope of -2 over 1, or -2. And then we're going to take it back to y equals mx plus b. We're going to plug in the slope that we know is -2x plus b, and we're going to solve for b. To do that, we're going to plug in an x and a y that's on that red line, which is 4 and 5. So we plug in a 5 for y, plug in a 4 for x, and that gives us 5 equals 8 plus b. Subtract 8 from each side. What did I do wrong? That's negative. That's what I did wrong. That should be -8, so this should be plus 8 to each side. And we get b equals 13. So we have a y-intercept of 13 now, which means that this equation is y equals -2x plus 13. All right. On the next slide, guys, we're going to give you one similar to that to do. Let's say that we have a line that looks like, we'll draw it like this. I'll make it a little bit thicker here so maybe you guys can see it a little better. All right, and we'll call that, let's call that line P. And we want to do a perpendicular line that goes through this point right here, which is at 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So let's find the equation of a line that is perpendicular to line P that goes through point 4, 6. Okay, guys, I'll see you next time.